Here's the final page of the study guide. Let f be a function that is continuous on the closed interval from x equals 2 to x equals 4. We know that f of 2 is 10 and f of 4 is 20. Which of the following is guaranteed by the intermediate value theorem? Okay, so we know that the IVT guarantees that we're going to hit all of the y values in between the endpoints as long as the function is continuous. And we do see that the function is continuous. So we're starting at 10 and we're ending at 20. So we know the IVT guarantees we're going to hit all the values between 10 and 20. Question A says f of x equals 13 has at least one solution in that interval from 2 to 4. That's exactly what we're looking for. 13 is between 10 and 20, so our answer is going to be A. All the other responses might happen, but we don't know for certain if they'll happen. The IVT just guarantees A is going to happen. With number 17, the FRQ, f is a piecewise defined function. It's a whole lot of function going on over here. So let's look at the different parts to it. Part A says find the limit as x approaches negative infinity of f of x. Negative infinity is less than negative 2, so we're being asked to find the limit as x approaches negative infinity of root 25x squared minus 9x plus 4 all over 7x plus 3. Okay, so this is a limit involving infinity or negative infinity. We want to take a look at the highest exponent. We see we have 7x in the denominator. We have x squared in the numerator, but it is the square root of that. So this numerator is really behaving like 5x. All right, so we have the highest exponent in both the numerator and the denominator. So we're going to be looking at the coefficients. And again, we don't want to use a 25 because we're taking the square root of 25. So our answer is going to involve 5/7. Now there's a little trick here, and that is it gets into the idea of the negative infinity. If we plug in a negative number for x up here, it will be squared, which makes it positive. All right, but if we plug in a negative x value down here, it's still negative. So we end up having positive square root of 25 over negative 7. So our answer is going to be negative 5 over 7 as opposed to 5/7. Part B, the limit as x approaches negative 2 from the right of f of x. Okay, so just to the right of negative 2 is numbers slightly bigger than negative 2, which means we're going with 6x plus 10. So this is asking for the limit as x approaches negative 2 from the right of 6x plus 10. And we can just plug in 2 there, so we have 12 plus 10, or 22. Part C, show that f is continuous at x equals negative 1. Well, for starters, we have 3 steps. The first step is to show that f of negative 1 exists. Here's where x is negative 1, and the function's equal to 4. So that's squared away. The second piece is to show that the limit as x approaches negative 1 of the function will also exist. Now we see negative 1 here and here and here. So this is because of the piecewise breakdown with the conditions, we're going to have to look at both the limit as x approaches negative 1 from the left and the limit as x approaches negative 1 from the right. Now from the left, those are numbers that are less than negative 1, and we see less than negative 1 right there. So that's our 6x plus 10. So we're taking the limit as x approaches negative 1 from the left of 6x plus 10, and that's going to be equal to negative 6 plus 10, or 4. As far as negative 1 from the right, now we're looking when x is greater than negative 1, or negative 1 is less than x is another way to look at it. We're down in this piece. So here's our function that we're going to use, the absolute value of x minus 1 plus 2. So we plug negative 1 in for that, and we have negative 1 minus 1 inside the absolute value plus 2, so we can see 2 plus 2, or 4. So the limit as x approaches negative 1 from the left and the right are both 4, so the limit will have that same value. And the last thing that we're going to write is that 4 is equal to 4. And now we've done the 3 parts to show that f is continuous at x equals negative 1. Part D says if a equals 2 and b equals 3, is f continuous at x equals 1? All right, so if a is 2 and b is 3, then we have 2x squared plus 3x, when x is between 1 and 4. All right. So we're interested at 1, so we're going to plug 1 into this, and that's going to give us 2 plus 3, or 5. But we also have to check from the other direction, because this is numbers where x is greater than or equal to 1. All right. We also have to look when x is less than 1. I'm sorry, right here, which is the absolute value again. So we have the absolute value of x minus 1, make that a little bit longer, there we go, plus 2, and remember that's valid for negative 1 less than x less than 1. So if we plug 1 in here, we have the absolute value of 1 minus 1 plus 2, and that's equal to 2. Since 2 does not equal 5, that means the limit from the right and the limit from the left are not the same. The limit does not exist, so the function is not continuous. So we're going to say no, all right, because the limit as x approaches 1 of our function does not exist. And that's all off the screen. Sorry about that. Okay, last but not least, if a equals 2 and b equals 3, what value of p will make f continuous at x equals 4? All right, so kind of building off this here, we have f of x is equal to 2x squared plus 3x. That's valid for numbers less than 4. So if we plug 4 in for this, f of 4, there we go, we're going to get twice 16 plus 3 times 4, which will be 32 plus 12, or 44. Now, when x is greater than or equal to 4, we have px squared plus x minus 8. And now, we know from the left we're getting 44, so from the right we've got to get the same value. So px squared plus x minus 8 is equal to 44. Remember, we're interested when x is approaching 4, so we can now plug 4 in, which means we have 16p plus 4 minus 8 is equal to 44. If we add 4 and we take away 8, that's really subtracting 4. All right, move that up over here. So we see that we have 16p will be equal to 48 if we move the negative 4 away and over to the right side, and therefore p is equal to 3 after some division. So there's our free response question answers.